Right.
Hey everybody, welcome back to the Unreal Engine live stream. I'm your host, Alexander Pascal, and joining me today, Richard Hinckley.
Hey,
it's good to have him back, right? Yeah?
It's been quite a while, yeah.
Yeah, it's really nice. Even though Lauren's not here, Ian's not here, it's actually just you and me, man. Like, it's some quality time to hang out, talk about code.
Still fun.
You know, it's really cool. Personally, I've done a lot in blueprints and all kinds of things in AI structures and behavior trees, but personally, I don't know a lot about code. And I know a lot of you out there have been constantly like, hey, Alex, maybe we should do one to cover the absolute basics. We'll talk about things like just how to get into it, going from not being a programmer at all to just trying to jump into very strong language like C++ can be very intimidating. So yeah, we definitely want to go over all the basics. Just kind of it might be a refresher for some of you that are more veterans, but for me, this is all going to be a lot of new stuff too. So thank you so much for coming out for this.
Thanks. Yeah, and that is a good point. It is kind of tough to get started sometimes, and I think. Actually, one of the advantages that we have here, well, I'll just side story about just personally.
Yeah.
So I started programming C, not C++, but C in 1995, and I think I told you this recently, but I didn't tell everybody else. So it was in August of 1995 when John Carmack of id Software released the Wolfenstein 3D source code to the public.
Pretty rad. Pretty rad.
Yeah, that was great. I mean, he couldn't release the whole game because Apogee had the publishing deal, but if you owned the game, you could take his source code and compile it with like Borland C, or not even C++, just C, and you could run your own, you could run your own game with their data. So that was it was a really great thing for him to do, and of course, Quake was out by then, so it was 2 generations of tech old, so it wasn't really a commercial problem.
No, it was good to learn on though.
But it was really, really great to learn on. So basically, I learned by looking at that code and making what were essentially Wolf 3D mods, just for myself. Just for fun, put some sprites from Doom in there, stuff like that. And that was a really great way for me to learn because I could see, all right, so here's something that clearly already works, and everything in here definitely makes sense because this is a released game that I've played a lot and I know works. So what if I tweak this? What happens? And if the answer is it crashes, don't do that way. But otherwise you start modifying things, you see how things work, and you kind of get to read the pattern. Rather than having to do it completely from scratch. So you sort of learn a little bit of the language and the syntax and a little bit of the structure or the methods of solving problems that a particular person used. And John Carmack is known for being pretty good at the programs.
Hey, he's pretty decent. I mean, I've heard the name before, I think.
Yeah. So not a bad place to learn from. So we have that here, though, because we have all of these... when you start a new project, you get the blueprint or the C++ tab. So you go over to the C++ tab, and pretty much anything other than blank will have a good amount of code in it.
Pre-built classes and a ton of info already kind of in there. Yeah.
Yeah, and then also we have the things that I've come on and done here with Lauren in the past. The tanks and the match 3, all that kind of stuff is up there. And
which the match 3 is up on the launcher tab, and this other stuff, if you go on our forums, you should be able to download different parts of it too.
Oh, and here's the plugin thing.
Yeah. Can we just jump right here really fast? Hop into it.
Yeah, I didn't even notice which project I had open, but yeah, it's one of these. I thought I had actually opened it. Oh no, I opened the tank one in Visual Studio. And and I have plugins open here. This is the one that I did with Ian.
Yep, that's another stream series.
The quests one.
Much more advanced. So yeah, we wanted to take that advanced stuff that you worked with and kind of break it down to the really really low level as far as what are we actually looking at, and for a non-programmer, really what is this stuff?
Yeah, so we're not going to go as computer sciencey as talking about state machines and that sort of thing today. It's going to be more of how to write program code that when you hit the compile button doesn't come back with too many errors.
Just some good practices.
So right off the top, we have a couple of questions or topics that we had sort of written down to start covering. And one thing that we got was a question of the difference between a CPP file and an H file.
Yeah. This is the most core thing to all of C++ really here.
So here we have, let's look at our missile. Why not? We have our missile.cpp. And here we have our missile.h.
How did you just do that, and what does that even mean?
Well, how did I do that?
Yeah.
I pressed Alt-O, which is a shortcut in Visual Assist X, which is a totally great program that we're not paid to endorse, but that a lot of people, in this industry, a lot of professional programmers used. In fact, when I first applied here, one of the emails I had was saying, hey, before your first day, let us know what you want on your computer, so IT will set it up. And I said, well, I really like VAX. I really want to use Visual Assist X. he said, oh yeah, that's just assumed. That's already on there.
I think
Didn't even need to say
this is such an important thing to bring up, because when you get into this, see how nice and clean and colorized and everything's kind of like chunked off and all this. Yeah, we have some visual assist stuff, and you're going to want that. Otherwise
it's this.
It's not exactly the easiest to discern. So definitely want to bring that up for you new programmers out there. You're going to want a visual assistance.
Yeah, I mean, and there is some stuff built into Visual Studio, and I assume there are some competing products for this, but this just happens to be the one that I've used. And once you start writing, well, I was going to say once you start writing bigger pieces of code, it's useful. But the thing is, if you use somebody else's engine, like Unreal Engine 4, because you don't want to write an engine from the ground up, there might be things like sweep single by profile. What does that do? Oh, okay, so it's in UWorld. Here's the H file version. Here's the CPP file version, which ties right into what we're about to discuss. So what is the H file version of this? Well, generally, all right, so a CPP file is a file that generally is where you write most of your code. The H file is also called a header file, as opposed to a C++ file, although they're both C++.
You know, I never really thought that much on it.
Yeah, but it's the header
point.
file. So the header file is generally included into the C++ file like this. And what this basically does is it basically says, all right, at this line, take everything that's in this file and just dump it right here. And the important thing about that is that if I want to write code that uses, let's say, something from our networking, the H file will be a very small file that just, in terms of, there's pretty much no code in here. You can see sweep single by profile. This is just one line that tells me what the function's name is, what the function's arguments are. It's basically the signature of the function, but that's it. There's no actual code. Like if we go down here, there's a big comment describing the next function. So this is just listing out what the functions are inside of this class. In the CPP file, this is actually what the function does. As you can see, it calls another function, but this is actually what it does. This is the real code for that function. You see the same signature appears right up here, except that it also specifies the class name, whereas this is inside the class declaration, so it doesn't have to. So the CPP file, in just the most basic terms, is where you write your actual code. The H file is where you describe what code is going to be in the CPP file. And what this lets you do is, if I have two things that both refer to each other, when the compiler gets down to one of them, when it's trying to build my code into an executable, it will say, okay, so you're talking about this function. What is this function? I've never heard of this. I don't know what to do with this. Or what is this class or this variable type? I don't know what this is. I can't compile this. So you put in the H file that tells it what everything's going to be. So it says, okay, so mental note for later, when you say UWorld, you're referring to a class that's derived from, you're referring to a, there you go. You're referring to a class that's publicly derived from UObject and also fnetwork notify. Okay, so now I know what you're talking about without you having to define every single function in the class and tell me what everything does and all the fine detail. It's just, that's what that is. So any other program that needs to refer to that functionality can include the world.h file, and then the compiler will know what things are before they're defined. And this avoids that circular dependency that, like, the world needs to know what an actor is, but an actor needs to know what a world is. Which one, you know, we have to define each one before the other one can be defined. And that's basically how that solves it. So think of it as really, I write my code in the CPP file, and then I describe what code exists in the H file, and that will pretty much solve it. And then anytime you come into a thing where your program doesn't, you know, says like this is an undefined class type or something like that, you probably forgot to include the H file for that class. So you include that up at the top of your CPP file, and you're good. That's the basics of it. It's, once you do it once or twice, it's second nature right away. That actually, I think, answered some of the sub questions too. What is the difference in functionality, and how do you set them up differently?
Yep, and then we go into includes and UE4 and how it works with includes. Yeah.
Yes, so UE4, it's not really much to consider. If you're using H files in the standard way, you won't even notice these rules, but UE4 has some things like this right here, or this.
Oh, that U class.
Yes, although we normally use generated body instead of generated U class body now, but whatever. This kind of stuff. So so UE4 will scan your H files as part of the compile process. It's a separate thing that's specific to this engine, and it'll see things like, oh, look, this is a U property, so the engine needs to be aware of this. Oh, this is a U property that's visible anywhere. So if we're in the editor, and this property should be visible, but you can't set it. So you can see it, like if you're in a Pi session and you pause the game, you can see this property because it's visible anywhere, but you can't alter it while the game is running because it doesn't say edit anywhere, it says visible anywhere. So stuff like that's specific to the engine. UBT, the Unreal Build Tool, and UHT, Unreal Header Tool, they'll go through and sort of take information out of the H files. But if you're using the H files in the standard way, pretty much the only thing that Unreal adds to it is you tag your properties like this, or you tag your functions with U function if you want them to be accessible anywhere other than in the code. Like, for example, to make them callable from blueprints, which is our next topic. So that worked well. Expose a C++ function to blueprints. All right, so how do you do that? All right, so first let's just cover how it's done. Oh, there are no U functions in this one? That can't be right. Oh, well, I guess there aren't. Maybe over here. Am I not pressing the right key? Whoops. H. Okay, I guess there weren't any of those. Okay, so here's a function. It happens to be static. We'll maybe go over that later. Doesn't matter. The point is that this is a function. Here's a description of it. And again, in Unreal, this description will be taken into the editor and used as the tooltip.
Yep.
So that's why we actually take the time to write reasonable looking ones that you would want people to read.
Yeah, you definitely want to make sure that you add in comments. It's just a good thing. And in our case, it actually becomes functional. So it's good.
Yeah, it's really important for your users that, find delta angle degrees. That could be pretty clear if your user is familiar with geometry. Delta angle is a little bit science-y sounding. I don't know. But either way, even if your user does figure that out, they might still think, so is this radians or degrees? Like, if they're familiar enough with geometry and trigonometry, they might ask that. So it's in the range -180 to +180. So that's a helpful little thing to add. So you just want to add as many of these little helpful tooltip clues as you can, because this will decrease the questions that come back to you and increase the speed of the other developers using your code. So it's blueprint callable. That is really all you need. Just U function, blueprint callable, that's it. We put it in the category of math so that it'll be grouped together with other math related functions. This, for example, is in the category of math and then the subcategory of rotator. This one down here is in the tanks category. What is this one? Get tanks game mode. Okay, so you can see why that's in
just get in the game mode.
Tanks, because it's specific to tanks. So blueprint callable is one of the options that we have here.
As opposed to blueprint pure.
Oh, well, blueprint, yeah. I wasn't going to say that yet, but yes.
Oh, I'm getting ahead of myself.
But yes, blueprint pure is one. I was going to say the other ones are blueprint implementable.
Mm-hmm.
So that's one where the function does nothing unless you make a blueprint function with that name. So this way you can have something that your artists, usually your artists, but possibly your level designers, or your regular designers will want to use. So for example, you could say on explode or on death, and we probably have an on death function. Oh, in a different class.
I think on destroy is probably something that we have built in, don't we?
We do have that built in, but this would be different because we don't.
Because you're calling it as a custom death function.
Yes, like this one, on explode. We'll get to blueprint native in a second.
This is such a great, this is a great event name, on explode.
It is. That's pretty cool. So when the projectile explodes, we don't. So we don't necessarily. We might want to do something specific. We might have a different type of explosion or a different gameplay effect based on what the missile is, and someone other than a programmer might want to implement that. Especially if it's an art thing. If it's going to spawn particle systems or induce some camera shaking or anything like that. It could be just anything. I don't know what it is as a programmer, and I don't need to. I just need to put a hook in so that whenever this happens, someone on the art team can say, all right, when this type of missile blows up, I want to do this art thing that I have in mind. And that allows me to do it. Now, as you can see, so I talked about blueprint callable. That would be a function that the blueprint user can call. It does some C++ stuff, and that's it. Blueprint native event is similar. We have a default version here, which just erases the missile, and that's it. Pretty simple. But if you wanted to do anything like have it flare up, do some explosions, and then destroy, you can do that by making the onExplode event in your blueprint. There's also blueprint implementable event, and that's similar to blueprint native event, except that there's no default C++ function. By default, it would just do nothing in C++. And then finally, blueprint pure. And blueprint pure, I have a little story about that from Paragon.
Yeah, we should definitely talk about that one.
We had a blueprint pure somewhere. Maybe it was in the previous file that we were in. Well, it was somewhere. Oh well. I know I saw one. Anyway, so I was so blueprint pure is if you've ever seen those nodes in blueprint, like a lot of the math nodes that don't have the execute pin going into them. Let's see if we can quickly. Oh, we do have tanks up as well.
Oh yeah, it is right.
I didn't realize they were both open.
Oh yeah. I always make sure that these things are all ready for you, man.
They were all ready. Of course they were. Let's just open up any old blueprint and see if we can find something. Here we go.
Yeah,
Great.
find some of those.
Tons of pure nodes right here. Okay, so this is not a pure node.
Yeah, anything with an executable there, but
this is. So you can see that the difference is this exec pin, right? So the program flow when the zombie walks goes from here over to there, and then it comes down this to here. But some of the information it needs, this is basically, just to explain what this does, this is basically a math function that speeds up or slows down the zombie's walking range, walking animation speed based on how much ground it's covering. So when it's running, the legs move faster. That's really all this does. And this gives you the play rate based on this equation. So this equation, all these are pure. They don't have the white exec pin going in. Now, here's the trick to pure. You are not supposed to modify anything in a pure function. So, like, for example, here's the division function. I can divide A by B without changing any actual variables. I just, A divided by B, here's your answer, done. That's fine. It doesn't change anything going forward. So all pures are supposed to be like that, and the reason is that that this node right here, the output, is recalculated every time. So if I did this, and then let's say I wanted to print out.
Mm-hmm.
I don't know why that's interesting. That went to the duration pin. I was thinking of the string pin, but
that's actually kind of funny that.
Yeah, but that needed a conversion. That is naturally where it should go. It's an exposed float pin. So I set the play rate, and then I want to print out what the play rate is this frame, and just spam the screen with every zombie every frame. I could do that. Here's the thing. Pure will, since it doesn't have an execute pin, every time you ask it, it will redo the calculation. So it will do the calculation here, and then when it goes to print, it will do the calculation again here.
And so if there's a slight change in there, then your print's going to be totally different than what your set play rate would be.
If I changed anything downstream from that equation, that would change it, but also I'm going to calculate it twice. So the thing that happened with Paragon was we were starting to do the function where you warp back to your base or you respawn after dying, and you have to pick which one of the spawn pads you're going to go on. At the time we were just randomly picking different spawn pads, so you didn't always go back to the same one, and we had a function to do that, and it would tell us what the latest spawn pad was, but it would also mark that spawn pad as having been used at this particular time. So it was a pure function, and I had two outputs from it. I had, just like I had here, like one here and then one to some other node. Well, when it got down to the second node, it would rerun the function, which means it would find another unused spawn pad because the one it had just used was now marked as very recently used. So it would go through and find the least recently used one, which is now another one, and then mark that as used, which means every time you port back, you're using two spawn pads. Yep. So if your whole team tries to port back in a relatively short time, all the spawn pads look like they're occupied by the time half your team has warped home.
That's not good.
Yeah, no, that's
This is
not
like
good.
those final guys are just not sure where to show up.
They can't go anywhere. It looks
Oh,
like
wow.
it looks like all the spawn pads are occupied somehow, which is not even possible. But not only that, but if you put a guy back and you say, oh yeah, also do the teleport effect on the pad. Well, when you ask what pad, it tells you a different pad. So you spawn back over here, and then the teleport effect happens on the next pad over for no reason. So don't use Pure for that. Pure should never modify things, although technically you can. It's a bit of a trap you don't want to fall into. Now, what might be a good use for a Pure node, if you don't mind the calculation overhead, is someone was talking about jump height.
Mm-hmm.
So,
you think we could maybe like do a little bit of that on here?
yeah, we might be able to.
Yeah. Yeah, we were discussing before this about how someone might need to calculate a different velocity for a jump height.
Yes.
Not necessarily just use a 1-for-1 space bar. The jump height is always set to this velocity, etc. And so
yeah, velocities are a little tough to do. So, because the fall off is there's a squared term in the fall off if you do the physics. I think the equation is 1/2 AT squared. I'm pretty sure chat will jump all over that if that was not correct.
we'll figure it out in a second. The slight delay, we'll find out.
Yeah. So So let's see. This is the sort of thing I would normally just Google or look up from code I've written in the past because I don't remember it offhand. But basically, since there's a squared term, having designers try to plug in random velocities can be pretty annoying. Usually, designers will know offhand, like, I want this guy to jump 64 units. And then that's too high, 56 units. And then you just try it out. So a Pure node would be really good here because you could plug in the gravity, and I'll just sample one up right now.
Yeah, I was gonna say, like, let's whip one up. I see some people in chat getting a little impatient, like, hey, when are you guys gonna start whipping something up?
All right.
Yeah, we're getting to there.
All right, chat. So
all right, Chad, we got you. We got
thanks,
you, Chad.
All right. So
Yep, start off with our U function.
Blueprint Pure. I like to put categories on things. I don't know if you're really required to. I think there will be default categories provided for you if you don't. And I'll make this look like the others, although any comment will work. Of course, this isn't a game with jumping in it, so that's fine.
For reference, if this was a game with jumping in it,
yes,
this would totally rock.
If this weren't a top-down game about tanks that don't jump. Let's see. The initial jump velocity from... Oh, yeah.
Yeah. Gravity.
Gravity and desired height. Okay, so... It's going to be a float. And because it's in a blueprint library, it's going to be static. Get jump height, or maybe calculate.
Yeah, okay, calculate, or make something.
Yeah, that sounds.
Yeah, you calculate something.
Get sounds like it was already calculated.
Yeah, and you're just retrieving it, because that's what, if you ever see get, it means kind of like retrieve, for you people who are new. All right, so we're adding in 2 float variables.
So that's pretty much it.
Yep.
And I'm just going to copy this signature for my convenience here.
Mm-hmm. Yep, so it is those 2 different inputs. It's got 1 output. Am I reading that right?
Yes, it will have 1 output, which is the float, and the 2 input parameters, which are gravity and height.
All right, cool. Like I said, I'm totally new to this too.
It's part of this class. So in the other file, just to explain why I have to do this here and not there.
Yeah, well, why are we adding in that little bit of info?
So in this file, I'm going to go to the matching brace with the magic button, thanks to Vax.
Yep.
And we're inside the class UTankStatics, which is a blueprint function library, as you can see. So all of these functions are implicitly within UTankStatics. In C++, the way you say that something is a member of some other named space is with the double colons. So since this, you can see, isn't inside of the class, right? It's not inside of a class.
Mm-hmm.
it's just sort of sitting out on its own. You have to tell it, by the way, this function belongs in here.
Oh, so it just kind of injects it into there.
Yeah, now technically we could just write the function right here. That's not as good a practice because you'll end up with duplicate copies of the function being compiled, because every time you include the H file, the compiler will see that and have to deal with it.
Oh, okay. So it's way better to have it running on the CPP. That way it only does it the once when it's called and all that, or whenever it's observed in this case, since it's pure. That's good to know.
Well, I'm saying for the compiler, when the compiler goes through, any file that includes this H file, as the compiler comes through, it'll see that and then go, okay, well, I have to like process this code now, make this into a function, and then it'll end up doing that a lot of times. And eventually, especially with things that are included, like if you did this in actor.h, something that's included almost everywhere, that's going to be a lot of wasted compile time. Your compiles are going to start getting way slower, especially on big projects. On small projects, you won't notice it. You know, or files that aren't included in very many places, you won't notice it, but it's just a sort of not a good practice. You just always put it over here. So let me see. All right.
Gonna retrieve some info?
Yes. So I'm trying to return, and this is physics that I know, but that I haven't done recently, so I may be wrong. Chat, feel free to step in here.
Yeah.
So let's see.
Did you need that equation? I think someone threw something at us, and I'm not sure if it's real or not.
What did they throw?
S equals UT plus, oh geez. I don't even know if this is the same formula you were looking for earlier. S equals UT plus 0.5 at power of 2. Ah, shoot. Sorry, the chat keeps jumping.
Yeah, but that's basically one. I think that's supposed to be V, right? Like that's 1/2. That's like the 1/2 AT squared.
Yeah.
Is that U or A?
Yeah, U. Yeah, that's what they did. Is S equals U plus that.
Okay. Well, usually that be an A. All right. So let me see here.
Just gonna double check the actual math. It's absolutely good.
Yeah. I mean, it doesn't matter. I could honestly return half of height times gravity if I felt like it. Like, it could be totally wrong because it's just to demonstrate how a pure function works, because we're not actually going to jump.
Oh, yeah.
Because it's a tank.
It's all good then.
But
and of course we're using the most powerful programming tool ever known to man, Google, to answer this question. That is not it.
That is not the answer that I was looking for.
No. All right. I think we just throw in some fake math.
Yeah.
They'll get.
I actually think that math that was given sounds really close to the correct formula. It's probably actually
and
right.
the person who posted it, I have a tendency to believe that they're not crazy.
All right.
You know.
So let's see. So we need our. Well, let's see. How long would it take this velocity to wear down to zero? Gravity. You know what? Give me a formula. I'm just gonna type in a formula.
Yeah. It was S equals U plus 0.5 AT squared.
Yeah. 1/2 AT squared.
Yeah, 1/2 AT squared.
Plus. So the initial velocity is 0. That's what's throwing me off, because you start from the ground. That first term is your starting velocity, which we're going to assume is 0 because you're jumping from a standstill. So 1/2 A times T squared.
Yeah. Oh, now they're just throwing fake math at me to mess with me.
Thanks, guys.
Thanks, Chad.
I knew we could count on you, Internet. All right. 1/2 A D squared. That's probably totally wrong, but it doesn't really matter. And we're going to make this a float. So let's talk about that for just a second, because this is for brand new C++ programmers. Again, I don't care if the math is right or not. I care if the code's right. So this is a double precision float.
Oh, can you exit out of the Incredibuild tab?
Oh.
Since we're not using it, it's just eating up space.
There we go. Now we'll have that. So, and by the way, we could shorten this. There's our value. So this is a double precision float. Takes up 8 bytes, gives you really, really precise, fine floating point values, like so a lot of decimal places, or a really high number that doesn't lose resolution. That's a float. That's 4 bytes, which is, 1, it's the return type, so we were going to lose that precision anyway. And 2, float is usually good enough. Float is bad for certain things, like timers that are supposed to go down to the millisecond and that might be running for months at a time. Not good for that, but good for most other things. most things in Unreal that are not integers are floats, like your character's position and rotation, those kind of things.
The capsule height, etc. It's float's pretty,
Capsule height,
pretty
yep.
much the most common one out there. It does, of course, have, like you said, the float precision error that you have to be aware of.
Yes. So we should be able to hot reload that. This I'm thinking more and more that this is incorrect because there should be some division somewhere, but I don't know. Normally this is the sort of thing that I would look up and then just sort of type it in and then try it a couple times. So while we're waiting for that, let's move on and see what else we have here.
It's the next link over. There you
go. Okay, we got that. BP Pure. Oh, well, actually, I think I just did all of that.
Yeah.
Yes, I did.
Covered that. So
okay, great.
Now that you're done with the BP Pure and how that basically sets up.
Yeah, no, this is a topic. This is one of the first topics I want to get to, but of course you have to say what a CPP file is first and that sort of thing.
Yeah. Otherwise, you have no context. It's very important to know.
All right, so pointers. We had a lot of questions about pointers. So start with just what is memory.
Yeah, memory management. Yay.
So memory is how you store data at runtime in your computer, and you can think of memory as essentially a one-dimensional address. Sorry. So you can think of memory as essentially a one-dimensional address, and so if you have a 4-byte variable, you'll start at that address, and then the next 4 bytes will be that variable's value. That's basically how memory works. So every time that you allocate a new chunk of memory, you're taking just this 1D chunk of space. So we have things like arrays where you can add theoretically as many things as you want until you run out of memory to the array. And the way that those will work is they'll take these chunks of memory in multiples of the size of the item you're trying to add, which is why you'll have things like you'll have an array of int32s like that, and you'll fill those up, and once those are full, it will take a bigger chunk of memory, like 5 ints. Once you fill up your 1 int, it'll go to 5 ints, and it'll go to 18 or 22 ints, and copy just bit for bit, copy the entire contents that you have into the new section. So it's important to think of memory as that. It's an address, it's a location where a variable can be stored. And if you look at that location through the eyes of another variable, like if I have an int array and I say, read that as a float, it might read that as a float. The value might not be what you expect, but it will be bit for bit the same thing as the float. So that'll come up later when we talk about classes and casting.
Now, before we get too far on this one, is it better as a practice to go with the raw pointers or to use C++ containers?
Oh, well, yeah, I think what are pointers for is the very next question. So yes.
Oh, well, there you go. Well, never mind. I got ahead of myself again.
We'll walk right into it.
I was just getting a question from chat there to throw it at you.
So let's suppose that we have an actor pointer. All right, so wherever this pointer is, wherever this pointer goes in memory, we're going to assume that that's an actor. And it's going to start as being null, which is the address 0, and which is special in the sense that you can't access it. It will crash if you try to, like if you say my actor and then you call a function on it like that.
Yeah, that's going to cause a crash because there's nothing to get.
Yeah, you cannot call to a null address. So this carries the assumption that the bits that you're looking at correspond to this class. If you had a pointer like this and you just made it point at some random location or something that's not an actor, it would still treat it as an actor and it would behave pretty much unpredictably. There are lots of safeguards to prevent you from doing this. So if I did this, for example, nope. Vax is telling you right away, or
bad
that
idea.
might not be
it.
Vax. That
Don't
might be
do it.
Visual Studio itself saying, nope, you can't do this.
Don't do
The
that.
language recognizes that this type and this type are not the same thing and are not compatible, so you cannot do this. Now, actor is a version of UObject with some extra stuff added. So I could do. By the way, the star indicates, this little guy indicates here that this is a pointer. That's what this is for.
Ah.
Without that, it would be assuming that you're creating an instance of that inline. Like if we did.
And not pointing to another one.
Like if we did, like if I say int x equals 20, that's an actual int. Within this function, int 32 we'll say, within this function, 4 bytes of memory are being temporarily allocated to store this value 20, and then we can do stuff with it. If I do this, this is, actually it's technically 4 bytes because it's an integer, or because it's a pointer, but this y doesn't have, you can't evaluate this as an integer. This is saying, this y is the address of some integer. So I could say that this y equals the address of, that's the address of, x. And now y points to x. Now here's where pointers get pretty interesting. This is the thing. If I do this, x now equals 22. Wait, that.
Okay.
I did the wrong thing there. If I do this, I just moved my pointer for y by 4 bytes. So y equals whatever the 4 bytes right after x were in memory. That could be complete garbage. I have no idea what that is. Don't do that.
Don't do that.
If I do this, I'm saying the thing pointed to by y increases by 4. The thing pointed to by y is this memory location where x is. So next time I ask what x is, x will now be 24. So y is not its own variable in the normal sense. Y is the location of some data, and x happens to be that data. Is that am I saying that clearly?
I think so.
I hope so.
Yeah.
I guess chat will tell me if I'm not.
No, they seem to be into it.
Okay, cool. So that's kind of the power of pointers, and that's why. So when we say UActor, or AActor, or UObject, or UWorld, when we get those things and we interact with them, that's sort of how we know that we're all talking about the same object. Even when it's a variable in a different function or it comes from a different place, the fact that it's a pointer means we're all pointing at the same piece of data. We're all reading and writing, on the same piece of scratch paper, more or less. Okay, so when do you use them? Well, first off, for any engine-created object like an AActor, you always use them. You'll never see that.
And actually, we had someone in chat. Hedge was just asking, what is AActor? What does AActor mean?
So AActor. So the original object type in Unreal was a U object, and when I say Unreal, I'm talking late '90s. Like I'm talking Unreal Engine 1.
Wow.
Yeah, it was a U object. So the U, of course, stands for Unreal, and the AActor. So actor is the parent class of a lot of things. Now, as I showed you before, an actor is a special type of U object. Okay, so an actor is an object, but it has a bunch of other, as you can see, it has a bunch of other things here, including that you can actually place it in a world, you can move it around, it can have these components attached to it, that kind of thing, where a U object is just a memory managed object within Unreal's engine. It's just an object that Unreal understands. So actors are all the things you see in levels. So our tanks, our missiles, our zombies, the ground, the sky in the background, the things that make noises, the lights, all of it. Those are all AActors. So the prefix A is used for AActor and anything derived from AActor, which is why you'll see a pawn, a character, a player controller, all that kind of stuff. So that's where the naming comes from. Other names, other prefixes, S for slate. We're not going to get into slate widgets today.
Not today.
But like a lot of our UI stuff. In fact, all of the editor is slate.
Mm-hmm. Sure is.
So S is for slate. F is for struct, which doesn't sound like it makes sense. Yeah, well, but if you read the Constitution now, they used to write the
it's
S
it's a really swirly. Like,
yeah, it's a really old
FS.
S.
Oh, okay.
It's also because the
Very
first
fancy.
structure that they ever wrote in Unreal was the float vector. So that's struct F vector, and we still have, to this day, F vectors as well as F vector 2Ds and lots of different F vectors. You want a 4-dimensional vector for some of that 4-dimensional chess that I hear about every time I listen to the news. So you have all these different F structures. You have F vectors, F, I don't know, what else we have? F math is actually a full class. F rotators, F quaternions for...
Yep, and we have tons of documentation on this as well. If they want to like go through and see every single possible prefix.
There are a lot.
There's a lot.
Well, every single possible struct, there are a lot. I guess there aren't that many prefixes, but so these are more of Unreal conventions. They're not language requirements, but as you get used to them, it kind of helps. Like you'll just see, oh, this is using an F whatever. Oh, okay, that's a struct. That's just sort of helpful. It's a convention that's stuck around. So you use pointers when you want to refer to these objects. You use pointers when you don't know how many of something you want, and you need to create new things dynamically. I could, for example, let's say I know I'm doing some like math equation, and I know that there are exactly 4 variables by the nature of this equation, and that's never going to change or whatever. Okay, so I can make an array that's exactly 4 integers, like that.
Mm-hmm.
That's exactly 4 integers, and in that case, if you use that little y, this y plus equals 4, or y plus equals the size of an int32, that's how many bytes an int32 takes up. That would let you, if you set y equal to the address of z, and you incremented y like that, you could walk through the different spots in the z array. So that's a case where you'd actually deliberately move a pointer.
That's pretty useful, though. Yeah.
Yeah, it's pretty useful. So this array of z4 right here is saying it's an int32, and there are 4 of them. So take that amount of space. That's 16 bytes. And z is the address of byte 0 in that sequence. And then z1 is byte 4, z2 is byte 8, and z3 is byte 12. So 0, 1, 2, 3, and those are your 4 numbers. So you could use a pointer if I wanted to do an operation on all of those things. I just put that in a loop and go through. But mostly you're going to use a pointer when you're referring to big complex game objects like actors, because the big thing is when we call something like this and we say float gravity, this float right here is a local variable. As soon as this function ends, that float disappears, the memory for that is gone, it's fine. And if I passed in something like my world's gravity, and I did something like this in the function, let's say I want to calculate all my jump heights for some weird gravity value. Okay, I'm calculating all my jump heights as if it's double gravity. So I can do that here, and when this function ends, this modification no longer matters, because I didn't modify the original variable that you sent in.
Yeah.
I modified this temp variable. With an actor, you don't want to do that. Let's suppose that each actor had their personal gravity, so we had to know whose gravity we're talking about.
What's this? Who?
Well,
You just making that one up?
Yeah. I'm saying calculate jump height for who, because suppose that each actor had their own individual gravity value in our game.
Yeah.
For whatever reason.
Yeah. Well, we got like a big dude and a skinny dude and like all kinds of various size peoples.
And they respond to gravity differently for some reason.
Well, they have various masses.
That is fine. Yes,
they have strange mass. How about that?
Yeah, look, it's in space. It doesn't matter. And
it's in super space.
I mean, Mario Galaxy got away with this pretty well, doing some weird gravity stuff. So I think it's acceptable. And again, not the physics show, or else I would have had that equation right. So we need to know this actor. The thing is, actors are kind of big objects, so I don't want to make an entire copy of that. Mm-hmm. I don't mind copying 2 little 4-byte floats when I come into the function. That's fine. But I do not want to make a copy of this entire actor object so I can just go, hey, what's your personal gravity? Thank you, bye. And then every time I call this function, I got to do that. That's that's a good reason to use pointers. If you're passing around a big object that you don't want to make a copy of, you use pointers, or often for structs, you'll see this. Let's suppose, again, we'll go with the Mario Galaxy example. Let's suppose we could be in a different gravity zone, so we need to know where we are. I'm just making up gameplay reasons for this. So this is a reference which says, yes, we're actually modifying this variable that you send in, but also that means you don't have to make a copy of it. And this is a const saying, don't modify this variable. I don't want you to actually change my location. I just want you to calculate something. So this is saying I will not modify this variable. So I think that pretty much covers why you want pointers.
Yeah, I think that's a pretty in-depth explanation of who, what, when, where, and why pointers.
Yeah. Okay. If there are more questions about it, we'll come back to it at the end.
Oh, yeah, I think I threw a couple into the Q&A.
I will beat horses to death and then more, because there's nobody here telling me, yeah, I get it.
Alrighty, yeah, so we'll dip into that one a little bit there too, yeah.
So garbage collection comes up. So typically in a programming language like this, when you want a new actor, if you didn't spawn it with us, you would say something like a actor, new actor equals new, make me a new actor.
Yeah. Well,
and
let's also say, like,
initialization parameters go here.
What is garbage collection at its core here?
Well, yeah, that's kind of where I'm going.
Oh, okay.
So the problem with this is that you would, at some point, you would also need to say to delete that new actor. And if you don't, if you lose track of that pointer, or if you just shut down without remembering to delete it, that is a leak. So that memory, basically you've asked the operating system to reserve this memory for you, and then you forgot to give it back when you were done using it. So if you keep doing this and you keep playing your game, eventually your system runs out of memory, and old games that had memory leaks in them would just crash. Because you have all these actors that, I just keep saying, can I have another index card to write some data down on? Okay. Can I have another one? And I never give them back when I'm done. Eventually you are going to run out of index cards, and then I'm going to ask for another one, which I need to continue playing the game, and you don't have any to give me, and we crash. So
this is a good metaphor.
Yes.
Did you just make that up?
Yes, but it's a pretty standard computer science piece of scratch paper type of thing. But yeah, it's basically like that. So garbage collection is where, when I'm done with the index card, I just clumsily crumple it up and drop it on the floor and forget about it.
Oh, and then I have to pick it up? Oh, wow.
Yes.
So rude.
Yes,
so
yes.
Rude.
Well, then we have a dedicated, not you, someone else will do it for you.
Oh, good.
But
I'm too above that.
We have a dedicated person to come in and pick them up off the floor and give them back, so that I can ask for them and then crumple them up on the floor later again.
Is this what we do to our interns? It's terrible.
I mean, if you have kids.
Oh, okay. Yeah, we got to put them to work.
You will be. Well, no, I'm saying no. Oh, the future for you. No, you are the picker upper of things.
Oh, the kids stuff.
Until.
Oh, so
yeah.
I should be picking up stuff. Kids should be handing it. Then
eventually, until they learn to do it themselves, and then until they learn that they can say no. Yeah. So you will be. So you'll be. These things will be picked up for you, which means that in this engine you don't ever actually have to delete things yourself. You also don't manually create them. You create them with spawn, and then to delete them, you tell the engine to destroy them, to take them out of your world, and then that's it. You don't have to track down the other copies of them. Let me explain why that. Well, yeah. So basically, when you delete these objects, they go into a pool of things that have been deleted, and then periodically, and you can set this in your project settings, but periodically the garbage collection routine will go through and take items out of that pool that are not needed anymore, clean them all up, and then that memory is available to be reused later for pretty much whatever purpose you like. Generally it's going to be other objects, but they don't even have to be the same type, because it's just a chunk of memory you got back. So a really nice thing about this is that sometimes when you delete an object, that object might be referring to something like a texture or a sound file or something like that. It could be referring to any other number of assets, and the garbage collector will know when there is nothing left that uses that texture. So in a game like Gears of War, you have a bunch of enemies that spawn in. They all have textures on them. You kill all those enemies, you move to the next area, the dead bodies disappear. Those textures are no longer referenced by anything. because they were only the textures for that enemy type. So those textures can also be freed up, and the garbage collector knows this, so you don't have to. See, it's pretty simple if you just allocate an object and then give the object back, but the problem is that if in creating that object, it loads another object, and that loads another object, and you have textures and materials and sound effects and other sub-meshes coming in, that's where you start wanting a program entity like the garbage collector to watch over this instead of you doing it manually. So that's kind of what the garbage collector is for. It makes sure that you don't leak memory. There's another feature of it which is really cool, which is if I have a U property, so we already have my actor, so we have your actor, why not? So we're sharing.
Your
now,
actor equals mine. Did you just steal my actor?
Well, we're sharing.
Okay.
We're sharing.
I'm calling it that, if I guess.
So, and yeah, so when we destroy this, what's nice is, let's pretend that these were both U properties instead of just local variables. When we destroy this, all the other U properties that are looking at this actor will know that it's destroyed. So your actor will become null by destroying my actor, since they're pointing at the same actor. This is great because otherwise, and this is how it was years ago, otherwise your actor could be pointing at the location in memory where my actor used to be, but now it's not there anymore. So you're pointing at some garbage memory that could be in use by another object, could be not in use anymore. Well, it definitely isn't in use anymore because my actor has been destroyed, but you just sort of be left pointing at, like, I think that, it's like if someone moved away and you still have their address and you go to that house. Like, they're not there anymore, but you don't know that. So the garbage collector updates things like that. So well, actually the U property reflection system handles that too. So this is all sort of tied into taking memory management out of your hands and making sure that it's done pretty much, well, as perfectly as we can get. I mean, if it's bug free, you'd say it's perfect. But that's the idea here, is that these chains of objects that are interdependent on each other should not be managed manually. It's a super bad idea, and it's not really viable anymore. So that's what our garbage collector is. That's what it does, and that's why you want to use it. And it can be tweaked in the project settings so that it can run as frequently or infrequently as you like.
Yeah, and that's very important in the context of Unreal Engine. You can actually go in there and make changes to how that one's running.
Yeah.
It's not just the defaults that you have to live with.
Yeah, it's pretty customizable, which is pretty nice. All right, so constructors. So in C++, you might be familiar with the idea of constructors. And let's see. So here's a constructor, for example. So for our missile, we have a couple of fields, and we wanted to set some reasonable defaults for these fields. Now, there's no comment on speed, but I guess speed is self-explanatory. So we want to have some reasonable defaults. So if you just make a basic missile, and I think we've had this happen before, where we forget to set the speed, and we're like, why isn't the missile moving? Oh, because speed is 0, right. So we set up these defaults.
It's important to give it some speed.
Yeah. We set up these nice defaults, and then you can sort of feel it out and change it as you like. And this is in the constructor. Now, normally in C++, you would, you'd say, like, whatever, a missile, my missile, good typing today, equals new missile, and that'd be fine. And then it would run this constructor right here on the new object that you just created. Now in Unreal, we don't do it this way. In Unreal, we have what's called a CDO, a class default object.
Wait. CDL?
CDO.
I heard CDL for some reason. That doesn't match up.
No, it doesn't.
Okay, okay. CDO.
That wouldn't make as much sense as CDO.
Class-derived objects instead.
So class default object, and that is sort of like the base template, like the base version that you make all your copies off of. And so basically, I think there was a thing in Portal 2 here. Yeah, there's a thing in Portal 2 where you had to go and they had the robot that was malfunctioning in some way, and you had to replace it with a different robot, and then all the robots they made were copies of that one. That was pretty fun little.
Yeah.
And that's this exact idea. That's what Unreal does. It when you go to make a new missile, it takes the default missile that it has and it copies it. And that way, things that you do in here that might be time consuming, or maybe you set something up in the editor that code doesn't run in the shipped version of the game, but the end result of the data you got could run. So it'll take that, it'll run that the one time when the engine starts up, and then it won't run it again. It'll just copy to the new objects that you create. So the only caveat for that, well, so the thing to be aware of for that is that you're getting a copy of the class default object, which means you can look up that class default object, see what the default variables are and that kind of thing. But if you modify it, every future one that you spawn will have that modification. That's not a feature that I use a whole lot, but it is something that you want to know is there and that you kind of want to know. I would generally not mess with it. But so that's how a constructor works, and that's how Unreal uses the constructor slightly differently. Now, the thing to consider though is static variables. So let's say number of missiles at a time. You know, some games have like you can only have 3 missiles on the screen at a time or something like that.
Yeah, they spawn in and then it starts locking you out of being able to spawn more.
Yeah, so
pretty typical of arcade games.
Okay, so we're gonna want to have. So we can put static variables in our classes like that. Make it whatever, it's fine. I think you usually make those consts. And did I say stat? I think I'm supposed to say const here. I actually don't remember the exact sequence for this. So this is, by the way, this is how you find things out in C++. If you're not sure what the exact sequence is, you try to compile it. And if it doesn't work, then you did it wrong.
Did it fail? There's a failure.
I think it did.
Oh. So here's how you debug it.
Multiple initialization.
Mm-hmm.
The other one it's complaining about is this one. Oh yeah, hey, why did I write that?
Why did you?
Oh, and why did I and why did I do that? I'm just supposed to tell you about the variable here, not
You're not
tell you
setting
what
it,
is.
yeah.
Yeah. Then over here, I tell you what it is.
Mm-hmm.
Okay, there you go. So that's how you learn not to do that. And I mean, I've been programming forever, and I still will occasionally forget like exactly what order you put something in or whatever. It just,
of course.
It just happens. Or there, I just absent-mindedly left that equals 3 in there and left the class name on there. Whatever. So here's the catch that I'm getting to. This is a great thing to do because as it's static, and we will get into what static is in a minute, as it's static, anywhere in the engine that knows what a missile is can ask a missile, how many missiles can we have at a time, and get this variable back. Anywhere in the engine. You don't actually have to have an instance of a missile to ask this question. That's what static is. Static refers to the class itself, not an instance of that class. So what do we say?
It's reference versus like the class. It's kind of what it looks like in Blueprint. It's like when it says like get a reference variable versus getting like the full class variable. It's kind of
or for example, I think we talked about this with DNA. I believe we came up with 46, right? Humans have 46 chromosomes, 23 pairs.
Yeah, something like that. I think we were just kind of guessing, but I think that's about right.
We might have checked our facts on that. I don't know.
Might have.
Chat biology, tell us. I think it's 46. So I could ask how many chromosomes a human being has. I don't need to have an example. I don't need to say like, Alex, how many chromosomes? I don't need a specific human being in mind to say this because the class of all human beings has this in its definition. Whereas if I wanted to say, how tall is a human? The natural question, I mean, you would either give me a range or you would say, specifically what human do you mean? Like, because they're not all the same height. They all have the same number of chromosomes though, so I could ask that question about all humans, but you can't ask about height without a specific instance of a human being that you're talking about.
Yeah.
So it's the same thing here. If I want to say, where is this missile, or what is this missile's explosion radius? I need to know exactly what missile you mean. But how many missiles can I have on the screen at a time does not require you to provide me with an instance of an actual missile. And that's a really nice thing about statics, is that you can have these general purpose things. We use it in places like the default socket name for spring attachments, which you can sometimes use for cameras. That's part of the class. So you don't need to, so the class uses it in its own code and other classes can use it in their code, so everybody's looking at the same variable, but you don't need an instance of a Spring component. Why am I telling you this when I could show you? Spring arm component. See, that's the name. That's the name that you attach your camera to if you're putting your camera on a Spring arm. But you don't actually have to know what this name is because you have this variable. This nice static variable.
A socket name?
There it is. Socket name, the name of the socket at the end of the Spring arm. Looking back towards the Spring arm origin, exactly where you want to be if you attach a camera to a Spring arm and put that on a thing. So, so that's an example of where a static variable is really useful. Okay.
And also, someone mentioned in chat, static is also mutable? I don't know what that means.
Do you mean const is mutable?
Wait, maybe it was that.
I think you might mean that const is mutable. I wasn't going to say that. It is a secret that you can actually override things being const.
Oh, okay.
But
const is mutable. Yep, no, that was it.
Yeah, I think that's what that person meant.
No, I would misread it.
Oh, you misread it? Okay.
It's me.
Thank you, chat.
Thanks,
yes,
Chad.
that is true. You can technically sneakily do that. I didn't want to bring that up because that's not a thing that you want to do at the beginning. If something is const, you generally don't want to modify it. I've found in my career one place, it was in Paragon, one place ever where it was appropriate to take a const thing and make it non-const for use in a local function. But I mean, we're literally talking, I've done this one time ever. So yes, you're right, const is mutable, but for now, pretend you don't know that. It's just sort of messing with things that you kind of don't want to mess with too much. All right, so creating classes, parent and child classes. All right, so we kind of talked about this a bit, but I'm not in this window. But for a missile, we want to write a couple properties for it. But you can see it's a few screens. It's it's a handful of functions, and then the rest of it is just please do what a general purpose actor in this engine does. Mm-hmm. I don't want to write it from scratch every time because that's an unbelievable, please write it from UObject all the way up to missile every time. So what we can do is we can inherit. We can say, look, this thing, it's basically one of these things, but, the tick function, we're going to override their tick function with our tick function, and we have our own version of begin play, and we have a couple extra variables that normal actors don't have. But other than that, it's basically just an actor. So anytime you've ever wanted to say, imagine this, but with this, that's what inheritance is. So this is how you do it. Now you may have seen this, public a something else. This is generally not a great idea to do. In Unreal, you go from one class, one parent per child. You just go straight down the line. Don't inherit from two different parent classes. Basically, the problem with this would be, suppose that the two parent classes have an identically signatured function, or they both have a variable with the same name in it. When I refer to that in the child class, which variable am I talking about? That's not really an answerable question. That's a C++ language level problem, so just don't do it.
It's like a rhetorical question for programmers.
Yes, we do. It's almost like a Zen cone. It's
that's a Zen cone. That's what I was thinking of.
There's not a good answer for this.
If code falls in the woods and no one's around to hear it crash, does it make a sound?
Yeah. So instead, there is a way to get around that, and that's to use our UInterfaces. A UInterface basically supplies a set of functions that you are expected to fill out, and then you call those functions. And that you can do. So if I had an interface like public my interface 1 and my interface 2 and my interface 3, that's all fine. And what's nice about this is, especially for beginners, is that even though I just told you there's a horrific minefield right there, you can totally just not walk through it. It's really easy to avoid. Just do this. You inherit from just one actor at a time. And at first, you're probably not even going to need to use interfaces. They're going to be a little more advanced, so I wouldn't even really worry about that. But just basically take the thing you want. It's usually going to be a actor, a pawn, a character, something along those lines, a player controller, a game mode, or a game mode base, things like that. basically look at the thing in the engine that does kind of what you want to do, and then you inherit from it and change, and you just go in and tinker with it. It's essentially kind of like modding, really. So a missile is just an A actor that has additional variables. Some functions have changed functionality, and that's it. It's actually pretty straightforward in that way. The other thing that's kind of cool about this is that I can take, let's just go into any piece of code here. Oh yeah, and by the way, if you want to do all the stuff that a regular actor does, Unreal provides you with the word super for all your U classes. Super is...
The word for parent?
Yes, it's the super class.
Okay.
So that's it. In this
Nailed
case,
it.
super means a actor. So there you go. So I want to do everything an actor does on begin play, and then also I want to set a timer so that this missile doesn't last more than 1 second. It just auto blows up when it gets 1 second out. So that's pretty simple. The other cool thing is that I can do this. Since a missile is a type of A actor, right? It's a child class of A actor. An A actor pointer can refer to an A missile. Pointers don't change in size based on what they're pointing at. They're just the size of a memory address, which is generally 4 bytes. Mm-hmm. So it doesn't matter that missile has a slightly bigger footprint than actor due to having extra variables. That's not a problem at all. This is just the pointer to it. And this means that I could take a list of actors and it could contain any kind of actors I want. Pawns, characters, missiles, tanks, zombies, anything. And they can all be referred to as A actor because that's the parent class. And any A actor functionality like get actor location, I can call on that. Now if I wanted to if I had this actor and I think we're in some other function and I think one of these actors in this array that I have might be a missile, I can do this with it. I can say some actor, let's cast you. And this, by the way, is how Unreal does casting. This is very similar to C in C++ casting, but it's just slightly different. The syntax is slightly different. Mm-hmm. I can say all right, I think this is a missile. So see if I can cast this actor to the type A missile. If this comes back as null pointer, then either some actor is null or some actor isn't a missile. Otherwise, if it comes back as anything other than null, that's a missile. So I can say if suspected missile is not null, then I can do all my I can explode or whatever it is I want the missile to do. By the way, a shorter way to write this is just this. In C or C++, implicitly, anytime you put up a thing like this, if it's a Boolean, it assumes you mean if it's true. If it's an integer or a float, it means if it's not 0. And since null is memory address 0 for pointers, any memory address that isn't 0 will pass that test.
Oh, okay. So your nice little is valid there.
Yep. Now here's one more thing we can do.
Cool. Just a heads up, we're getting a little tight on time.
Just because I like this. Okay.
Mm-hmm.
We can do this. Now the advantage of this is called scoping, which is that this variable is declared inside of these braces. So as soon as you go outside of those braces, it's gone. This variable, suspected missile, will only exist in here. So out here, it no longer knows what I'm talking about. It doesn't exist out here. So that's just a way that you can keep that really clean, and all your code that you would only do if it's a missile is in here. You can't accidentally refer to a null variable outside. All right. I think we just covered a ton of this.
Yeah, it seems like that one's kind of knocked out there. Well, we're actually a little bit tight on time, so we might have to jump to Q&A, and then might have to come back on and address a couple of these. People are being very helpful in chat, pointing out things that we should probably cover in another stream, other ways to kind of ease people into different avenues to these things. So thank you all so much for your feedback, by the way. We do these live so I can interact with you and get your info like live.
Yes, that'll be very useful to us in future streams.
Cool. Right. First question here, if you are ready.
I just scrolled that off my screen by accident.
Scroll on down and you'll
Let me try that
see
again.
in there.
All right.
Demir Halilovic is asking, when you create a config variable in BP, can you mouse over to you can mouse over to see the INI config path? Is there anything similar in C++? How can we create config variables of arrays of structs inside of a oh wait, that's two questions. Sorry.
So
first question is there anything similar in C++?
No, there just isn't. The whole concept of config files and everything like that is an engine feature of Unreal. I mean, obviously it's programmed in C++, but you would have to program your own. The language itself doesn't support that.
By default.
Yeah. So let's see. What can we do to have the fastest possible CPP compile times? Okay, so fastest compile times. 1, include only the H files that you actually need. Because like I said, when the compiler sees, man, I really got to pay attention to what window I'm in. When the compiler sees something like this, or this, it goes to that file and it compiles that entire file. So it's saying, I'm doing this CPP file, all right, let's go. Okay, there's an H file, let's do that one. And then any H files that are included by that H file, let's do that one. And it'll go through and do every single one and then finish the CPP file and say, okay, that's done, next CPP file. So if you include H files that you don't need, that's wasted compile time. If you include an H file inside another H file that you didn't really need, like if I just, instead of putting this here, let's say I put it like here instead, that would mean that everything that includes missile.h also includes, what did I just say, damage interface.h and tanks.h, which they might not need. So put as many includes in the CPP file as you can, because things in the H file might be included by multiple CPP files, and thus you're going to hit that multiple times. So that's one of the best things you can do right there, is clean up your include H files, include the bare minimum you need, and put everything you can in the CPP file so it's not included by multiple other CPP files. I think that alone, that's that's
the practice you see that always kind of freaks you out too, right?
Yeah. So that alone, I mean, actually, when we did the include what you use refactor, we got something like 50% improved compile times on our whole engine.
Yeah, that was just a couple of major releases ago, and it was a huge deal. Definitely check out our release notes if you guys ever want to see what we've been up to with things like that.
Yeah, so I would say that is like the #1 thing you can do.
Oh, right. How should one declare non-standard C++ variables like f input action key mapping? I feel like
how should one declare? So that's not a standard C++ variable in the sense that that's a
like an engine.
That's a variable that we declared.
Provided by us.
Really the same way. I mean, you know, kind of like how when I was just messing around, we're just like this. Like, here you go. Here's f hit result. It's really the same way as any other variable. The only trick that you would have to know here, I guess, is that whatever H file you define that in, make sure that that's included, or that you, pretty much make sure that that's included. There are other ways to get around it for classes if you're using only pointers, but that's the big one. Just make sure you have the H file included. You can do this also, by the way. A something, whatever, I'm making that up. So then down here, I can make a pointer to it, and I can check if it's null, and I can set it equal to some function that returns a something type pointers. That's all I can do. I can't look inside it at all, and the reason I can do this is because the pointer is a set size regardless of what's in the class. So as long as I never actually look inside it, the program will trust me, the compiler will trust me that at some point there's going to be a class A something defined, and that's what I'm talking about. But that's only if you're just going to use it as a pointer and not call any of its functions or look inside it at all. All right. As someone who's used to pure programming for other engines, can you explain how to use C++? Okay, so by pure programming, I should read the whole question because not everyone else knows.
C++ and blueprints and units. So yeah, so the whole question is, Marman is asking, as someone who's used is used to pure programming from other engines, can you explain how to use C++ and blueprints in unison?
Thank you.
When to use what /workflow?
Okay, so that's a little bit, it's not exactly a programming question so much as a gameplay programmer question, but we'll go with it. It's a good question. So instead of just programming everything yourself, a lot of times what you'll do is like that onExplode function where when this missile blows up, I know that some artist or designer is probably going to want to do something here, or probably going to want to know that this missile blew up. So I'll put in a a blueprint function, a blueprint native event, for example, that says, let them have this in blueprint if they want it, and as the default behavior, just destroy the missile because I don't care. And then that way they can override that behavior. They can do whatever they want. They can delay it being destroyed if it's supposed to, stay on the ground and burn for a while or whatever it is. But that's just the key, the or whatever it is part. I don't need to know what that is. I just give them a thing that lets them have access to it at points in the code that they would probably want to know about, like when the missile blows up. That's the kind of thing that they'd probably want to know about. And you can collaborate with your designers if they need to know, like, I need to know every time it passes within radius 5 of a zombie. Then there are ways you can do this. You could say, all right, we'll put a sphere on there, and then we'll have the on overlap event for that sphere, and then when that sphere runs over a zombie, you'll get the notification, and you're done. If you need something else, something more specific, again, what your designer asks for, you just sort of have to work back and forth with them. But in general, things like, when the missile explodes, you kind of know they're going to want to do something with that. So you basically make these blueprint functions according to their need, and sort of, it's sort of a question of your workflow and pipeline with the other person.
It really does come down to the case-by-case basis as far as what your game needs, as far as what the people on your team are going to need you to expose for them and all that too.
Yeah. That's a good question.
Paraswarm asks, when is it best to use structs versus classes?
Okay, so here's a C++ sort of secret.
A little trick for you.
Classes and structs are exactly the same thing. The only difference is that by default, a struct's members are set to private access. No, a structs are public and a class is private by default. That's it. Technically, they're the same. There are other cases, though. Well, all right. So generally, you want to use classes in this particular engine where you have a big object that you don't want to have copied a lot. Things like UWorld, AActor, stuff like that you want to pass around by pointer a lot. And structs you want to use as things that, so for example, an F vector saying like, where am I in the world? Or how big is this capsule, right? That should never be null. So I just use a struct for that instead of a class. Structs are just easier to use that way, and they kind of look better. And then you can pass them around and make copies of them if you want to, pretty casually. You want to make sure you're not wasting cycles copying things, but that's more of an optimization question. So I would say in raw C++ programming, it doesn't really matter. But in here, I would say for things that are just little pieces of data, struct. For things that are like game objects, class.
All right. We have time for about one more question.
All right. Why set the default value in the constructor instead of the header uproperty declare? I think you actually can set them in the header file, but it's kind of bad form, and people, other programmers will have to pick through your header file.
You don't want to be judged by the programmers.
Yes, you don't want to have them be like, where is this default coming from? I don't get it. So it's just sort of a convention to do it here. You could actually also set it in begin play, but that would mean that every time you create an object, it sets this value as soon as it begins playing, which means that you wouldn't be able to override it. And also you'd possibly waste cycles setting it when it could have been preset. So basically the answer to that is pretty much it's convention, and for everyone's convenience that all that stuff is done right here where everyone can see it in the same place.
Cool. All right, that's about as much time as we have for today's stream. We actually went a little bit over for y'all because we want to make sure we hit all these Q&A questions and all that.
Yes.
Thank you so much for coming out live. Thanks,
yes,
Clint. You always get the
best,
best transitions. Doing it live every time. So yes, thank you so much, Richard, for coming out and doing this. We'll probably have to come back, do a more follow-up stream to talk through it and actually do some examples and whatnot. Oh,
yes. Oh, and I was going to say, definitely give your feedback. If it was too detailed or not detailed enough, or there were things you felt were skipped over. This is our first one of these, so I don't expect that this is our best one.
Yeah, it's not gonna.
Yeah, like this. I hope this is
100%.
not our best one.
And I would hope that we can improve upon these.
Yes.
But we do see the need to reach out to you, the new programmers, the people out there who are basic level programmers or artists trying to get into programming and try to answer your questions. Try to cover exactly what C++ is going to do and how Unreal works with it. And I feel like we knocked a couple things out, though I am seeing a lot of feedback. But do come to forums.unrealengine.com. There's an events section which we put all of our live streams under. If you go in there and you put your feedback in the event for getting started with C++ and UE4, we'll see it, we'll come in there and we'll check it out, and we'll try to make sure we get it covered in a future stream.
Yes.
It's very important to us.
Yeah, looking forward to seeing you guys on the next one.
Yep. And before I forget, Thursday, we're going to have Zach Parrish come on, and we're going to do the photoreal bust, so the new bust head that is a sample project in the Learn tab of an Unreal Engine. We're going to have Zach come out, and he's actually going to break it down because he wrote the docs for that. We're going to talk about eyes, skin, hair, all the fun stuff that makes a character, and all that. But yeah, I'm actually about to run back out to East Coast Game Conference because I'm in the middle of a conference too. So ECGC,
Oh, that's right.
Yep. So if you're at ECGC, I will see you there. If not, I will see you on Thursday. But thank you so much, Richard, for coming out. And thank you all for coming out and watching. But we're going to let y'all go now. Bye-bye.